But anyways, this week we are going to talk about filtering and the final project. So as far as filtering goes, for the most part, it should be fairly self-explanatory. Nothing too crazy new, except for there are a couple ones that kind of seem to get people the most, which there isn't anything in the exercises about them. And I'm not sure about the quiz, but those ones are the any, in, and some. So I wanted to go over those because for the most part, the other ones are stuff that we've hopefully seen before. And those things are, simple things like, greater than, equal to, less than, those kinds of things. You'll also want to pay special attention to how parentheses work with the and or clauses to combine logic. So for example, this, like, I know we did one of those in the second week of class, and there was a question on the quiz that stumps a lot of people because it's kind of tricky because it says and, but really it's an or. And anyways, I know I've talked to a few people about those. But anyways, I wanted to go over the in, any, and some clauses because those ones are I guess the more tricky ones. So the in is actually pretty simple because it's just a list. So for example, where rating is in G or PG. So pretty normal. Basically just check to see if it's in a list. And so this would return any rating, any film with the rating G or PG. So it's just like saying, oh, as long as it's one of these. So that's really handy. You'll use in quite a bit. It can also be used with a subquery, which we'll talk about subqueries in the future, so don't get too hung up on them. But basically, a subquery returns a list. So basically, imagine if that was just the same thing as saying G and PG, and we'll talk about that more in a future week. But let's go over the wildcards as the like, which makes sense. Nulls you have to check for manually, and maybe they don't cover the in and any. So we're going to go over that. So just like the in, so let's we'll use the same example. We're going to select everything from film. So here's all of our films, and we have rating over here, and that's kind of what we're going to be checking for. So just like in the previous example, I can say where rating is in PG or G. But we should only have PG movies and G-rated movies, which it looks like we do. Basically, this could be rewritten to say rating is equal to PG or rating is equal to G. Basically does the same thing. The list just makes it a little easier. So let's change this from rating to rental rate. So let's say for rental rate, we kind of wanted to say, let's have a list here. So let's say we were going to say 99 cents and let's say $2.99. Kind of our two cheapest options here. We could say in to kind of get those in a list, right? But let's say we also wanted to, let's say we want to kind of do a little bit different. So let's say what's nice about the any or some, which they are the same thing. So any or some, both keywords do the same thing. We can say any is greater than or equal to any. Let's actually say less than. Let's see if there's any less than. Oh, and we get a issue here because we need a column. So this is where we need to build our subquery. And the subquery, like I said, is basically a subquery that will return certain things. So let's select the rental rate of a film. Let's say all of our G-rated movies. I'm going to say distinct. So what's nice is we can pull this now. This unfortunately has all the options. So I kind of want to narrow this down a little bit more. So let's actually select everything from here and just see what films we have, because I kind of want to just select a specific one like Ace Goldfinger. Let's use that, where title is equal to Ace Goldfinger. Instead of selecting everything, we are going to select rental rate. There it is, $4.99. So what we can do here is this is just going to be 1 and it returns $4.99. So this is essentially, if we wanted to say where rental rate is equal to $4.99, this is essentially the same thing. So there's that, but we're going to put this in a subquery. And instead of having to manually type this, we could programmatically make this work. You know, let's say we wanted to compare one film versus the other to see what the price differences is. And so this is going to find all the movies that have the same rental rate. Now, let's say we wanted to find all of the movies that have a rental rate that is less than a list. And I'm going to select the rental rate where, and I'm going to kind of just hack this a little bit, where rental rate is equal to $4.99. We get just a bunch of $4.99s, but that could be any category of things. So basically what we're going to do is we're going to change this to say it's got to be less than any of those. And we're getting an error. Maybe MySQL doesn't support this one. Line 6. Still nothing. So let me just pull up an example since it doesn't look like this one's supported. All right. So basically the any operator is going to let you do versus the in, because the in lets us check as long as it's equal to a specific list. And any is going to do the same thing, but it lets us use other operators. So just like in our little example here, we were trying to see if it's greater than any of the following that's returned by a subquery. So you can see here where they're basically doing the same thing. They have an operator, which is greater than, less to, equal to, so on and so forth. So let's say we were building a website that lets us compare prices across various stores. You know, we could say, hey, this is our price. We want all of the prices that are less than ours, because like maybe we're Walmart doing price match. You know, so for something like that, even though this isn't going to work, let's just kind of pseudocode it. We're going to say select.
There's an extra semicolon in there. Is that what's causing it on 11?
Oh, let's try it. That might be it. Yep, that's what it was. Perfect. So, yep, that's what it was. So, yeah, basically it's going to find all the films where their rental rate is less than whatever's returned by this list. and any of them. So it's basically like having a, because to me, in is pretty easy to understand. So in this case, we're going to get all the $4.99 movies because that's the in. Basically, it's, to me, it's like saying like, hey, as long as a rental rate is less than anything in this list, that's kind of what any and some do. So as long as a rental rate is less than any of these, then we're good. And the big confusion most people get is that some and any do the exact same thing. They just are different names for the same thing. So don't get confused between any and some, because they're the exact same. And the way I remember it is any and some, basically you have to have an operator. So essentially we could do this equal to any, and this is actually the same thing as our in. So equals any is basically synonymous with in. And you'll notice we get the same row count, 337 rows each time, depending on, no matter which way we do that. So the any and some let you do an operator in front of it to like do, greater than, less than, that kind of stuff. And in just does equality. All right. Like I said, I kind of want to keep moving because we do have a lot to cover, because we are going to talk about the final project, which hopefully most of you decide to do. The final project is actually, I really recommend doing the final project versus the final exam for two reasons. The first one being is that you are going to learn more, which is the most important. But the second reason is that you are likely to get a much, much better score. With the final projects, as long as you meet the requirements, odds are you're going to get 100% on it. So basically, as long as and you can double check with me, and basically it's almost a guaranteed 100% if you're willing to put in the work. The exam, on the other hand, it's an exam. Once you get your score, that's kind of how it is. And obviously I'm willing to look at questions that might be problematic, but you only get one shot at it. Whereas with the final project, you can continually work on it. So that's the kind of that. But let's go over what the final project is and the deliverables for it. So, and I would highly recommend actually starting on it this week. But let's talk about what the final project involves. So basically, you're going to design and build a database. And you're going to design and build this database, just the database itself. It has to have certain requirements. It has to have at least 10 tables, which we'll talk more about in a little bit. But you're going to build this database, and then you're going to build some test code for it. And then you're going to actually kind of like build like a presentation and materials as if you were trying to do like a sales pitch to like build whatever it is you're building. So let's say that I wanted to build a website that would do recipes. In fact, a good idea I've always had is why doesn't the family search do recipe sections on their family history stuff? I think that would be really cool. But anyways, so you could kind of build that yourself. So if I wanted to build like an application, a web application that would let you record, set up like a little family shared cookbook. That's kind of what I'm going to do for our kind of to like help you get an idea of how to go about it. So that's kind of the concept I'll use. Basically, I would build the database, and then I would build this sales pitch where I'd actually have like what the UI might look like. And it's called a UI map. UI stands for user interface. So you kind of like do a wireframe, and you just like do like little buttons, and like, oh, if I click this button, this is the code that will execute against the database. And we'll talk about it along the way. I also have quite a few past videos that I've recorded if you want to get a head start. But we're going to go over it here in just a minute. So I'm going to click right here. We're going to go look at these actual deliverables. So the first thing you need is an ERD. And the beautiful thing is you can either code the database manually and then generate the ERD from it, or you can build the database from the ERD. So either way, the ERD is actually like one of the easiest deliverables. Really what the ERD is for is to like, show the design, because, there is a rubric here, and I'll be honest, I'm not really strict on the design errors because I know we're all learning. If it's really messy, I might dock some, but I mean, it'd have to be pretty messy. So, and what I'm going to say along the way is if you ever have any questions or want some advice on like, oh, how would I do this? Just feel free to ask in Teams. More than happy to help. And we're going to actually build an ERD for mine today. The second thing you're going to need is test cases for CRUD. If you've never heard of CRUD, it's really common nomenclature. If you've ever heard of a REST API, CRUD is along those same lines, where basically database operations are largely you either create, read, update, or delete. So the whole idea is that we have CRUD operations against all 12 tables, because then we're ready for our APIs. And that's kind of the whole idea. So that's why you have your create, read, update, and deletes against all 12 tables. And really the 12, I'm okay with 10. And the test cases should include, so here's where our maps are: an index that maps the user interface to your test cases. So basically, you map out your user interface. And if I'm like creating a new user, I'll have like a little diagram of where I put in my name, my email address, and a password, and hit save. When I hit save, that will run X code. And we'll talk more about it because, I have little tricks for how you can number that and whatnot. And that is your mock-up of your user interface form. So basically, you just have to take your user interface and map it to the code that'll run, whether that's your CRUD or your test cases. Because there might be times it's like, oh, if I want to show, for example, a lot of people do stores. If I want to show all the products available on my store, that's not really it counts as a CRUD, as a read, but you might query against more than one table. So that's a SQL test case where you might actually query that file. Now, most of the time, once you build your database, you have most of your CRUD statements, and then you just have to kind of like write a couple select statements, a couple update statements, yada, yada. And then you have all your deliverables. And then you create your PowerPoint that, like I said, I'd like to think of it like a sales pitch. Like if you were trying to get someone to invest or provide capital to get your project off the ground, explain the business purpose of your model. Like who's going to use it? What are they going to use it for? Why did you design the UI the way you did? And then talk through your deliverables. Like go through like what the user would experience and what happens on the back end. So, if I were doing, I'd say, hey, the first thing I'm going to do is create my account. This is the screen I see. I fill out the information, I hit save. And when I do that, this is the code that creates the user on the back end. And then once I'm logged in, this is my login form. This is what happens when I log in, and then so on and so forth. Walk just through one process. It doesn't have to be this all-encompassing, completely fleshed out thing. It just needs to walk through like a basic concept. So if you're doing a store, walk from the moment that they see products on the page to when they check out. Kind of just like one flow that kind of covers the bulk of the concept. And I'm going to pause there for a minute before I dive into actually starting to build a database. Does anyone have any questions about the deliverables or just in general?
Yeah, I've got a question. What you say it says the mock-ups of the user interface. Like, am I drawing something? What am I using to create this?
Whatever you want. You can wireframe it. I've done some like as examples just on my iPad because I have a pencil thing or whatever, and I'll just quickly like almost napkin draw it. I've seen really sophisticated ones, and I've seen really basic ones. So yeah, doesn't matter. You can use whatever is comfortable to you.
And just not crayons.
I'm actually okay with crayons, to be honest. Yep, I'm completely okay with crayons. You'll see because later, basically what I like to do is I like to start, and this is a good segue. So basically what I like to do is I like to, in every weekly meeting, I'll add a little bit to the final project discussion, I guess, if you will. So like tonight, we're going to go over basically just like trying to get our heads around, which is we did the reverse engineering project last week. So basically I'm going to kind of do that again, but starting from scratch. Like, okay, here's this idea I have. Here's some common concepts, which we're going to flesh out an ERD database with the relationships. But every week sequentially after, I'm going to add a little bit. So, maybe in a couple of weeks, we'll get to where we're going to start talking about the UI maps. Because I try to keep it on course with maybe where you should be. It's kind of like a little motivational, like, oh, and you'll start seeing it in the weekly announcements now, like, oh, at this point you should be probably starting to finish up with your database design and actually starting to create it. Or now you should be working on your CRUD statements. Now you should start be working on your test cases, along the way. So yes, we will talk more about it because you'll quickly see that a lot of my UI maps might as well be done in crayon because it's about the quality they are. Okay, so let's start. So I'm going to use actually that, let's do a new model. So I'm going to do it with the UI just because I think that's how most people are going to do it. And I actually read all of your week 1 papers. I kind of use those as kind of like a gauge to kind of see how many of you like the UI. And I actually really like the prompt because it tries, I like that it alludes to the fact that command line is like really, really good. And don't get me wrong, I use command line a lot and I think it's vital to know how to use it. But I'm okay with doing both. But I really like to kind of view how many people are willing to go against the grain and say like, I actually don't like the command line. I'm going to use the hide, which is completely fine. And a lot of people actually put that they thought it was better. So we're going to use it just because that's kind of seems what general consensus is. And I think for this, it kills 2 birds with 1 stone. And I think it's easier to kind of visualize as you do it, especially for beginners. Because I usually actually just go start scripting it because I like to have code there ready and pre-built, and I like to have control over the code. But we're going to do it this way and let it generate the code for us, and that's kind of what I'm going to hopefully walk you through. So first thing we're going to do is I'm going to build a new model here. So the first thing I'm going to do is I'm going to click here, and you'll notice when I click this little table button up here, it says schema and it says MyDB. I'm actually going to change that. So I'm actually going to click here, and I'm going to, where it says MyDB, that's kind of the default. I'm going to edit schema, and I'm going to rename it. And I'm going to call it, since I'm doing a cookbook, I'm going to call it Family Cookbook. Let's just keep it simple. That's the name of my database, is Family Cookbook. We're going to leave the character set all the same. Yada, yada. I don't have any references yet, so I'm just going to leave that as it is. And we should be good. So I'm going to close this. Now, when I click on this, the schema is Family Cookbook, which is perfect. So I'm going to click here. And this is where we're going to start building our tables. So basically what I'm going to do, and let me actually see if I can zoom in here. Zoom in. Oh, it only zooms that part. It doesn't zoom the other. Okay. What I'm going to do is I'm going to start with the root. So I always like to kind of start with like the main kind of component. And this one's going to be a little different because I know that it's going to be a web application. So, and I kind of always use the same kind of fundamental table, and believe it or not, they actually have a template for us. So I'm actually going to delete this and show you how to do the template. So up here where it says template, I'm going to choose user and then click, and it kind of creates this user table for me, which is kind of nice. You can build it by scratch if you want to. I am going to use our template, but with a few adjustments. So I'm going to create what's called a system user ID. Actually, we'll just call it user ID. In other database systems, user is a reserved keyword, meaning that you can't use it. So, and created time is what it was. Again, that's where I get nitpicky. Okay, so user ID, that's going to be our primary key. We want it to auto increment, and we want it to be an integer auto increment. So now this is where some of these options are kind of nice. So when we build our table, we want a primary key. And this primary key we can mark right here where it says PK. And then the next one is NN for not null. Then it's UK for unique. So the other thing I'm going to do here is under email and username, and I'm actually going to delete username. So under email, I'm going to mark not null because they need to have it, and I'm going to mark unique. The reason I want email to be unique is, let's say that we set up a function where they can reset their password, or sign up. If 2 people sign up with the same email, what's going to happen? Yeah, there could be problems. And so what we do is we set that to unique, so it's impossible for two people with the same email to sign up. And hopefully, we're building a robust system where we send a verification email. So I can't go sign up with Brent's email. And then when he goes to sign up, he's like, I've never signed up. Why can't I sign up? And the next thing I'm going to do is password. We are not going to store a raw password. We're going to store a hash password. So we want that to be nice and long. Varchar 255, not null. There we go. And created at, we are going to have be defaulted to current timestamp. Basically, that means that we don't have to worry about actually putting data in there. It will automatically put it if we don't provide one, which is always nice. And then the last thing I'm going to do is I'm actually going to name this system user. And the reason I rename mine system user is, again, not all database systems let you use user as a table name. So I like to call it system user. So that way, if I want to convert this code to Postgres, it's just that much less of a lift, which isn't a huge deal. So I'm going to leave this just like this. So here's our system user. Let's add a little bit more. So let's say we want to add I'm trying to think about how complex we want this to be. Let's do, we're just going to add names in here. We're going to keep it a little bit more on the simple side. So I'm going to add first name. We'll give people 60 characters. And when we have a varchar, we need to specify how long we want to allow that to be, and which can be a big deal because when we're planning a project like this, we are not only thinking about the database, but we're thinking about how we're going to display this data. And so if we allow names that are enormous, we have to provide enough space in the user interface to display those names. So something to think about. Maybe not necessarily for first name and last name, but probably something we want to think about for other things like the names of recipes.
Are these data types something that can be changed down the road?
Yes. Until you put data in. Once you have
Okay.
data in your table, it can
It's
be
done.
problematic. You can actually change it, but you might have to move the data to a temporary column.
Yeah, like
and then
export it
move
out and then re-import it.
Yep, exactly.
Okay. So
But
basically, you
I'll
want to get that right from the beginning if you can.
Yep. And I'm actually going to show you a way to have this scriptable. So basically what's preferred is we design this, but really it all lives in code. So if we want to say, hey, like I want to make this change, we can wipe the whole thing out and regenerate it like 2 commands. So that way, like, oh, little changes, we can just delete everything, rerun the script, and it recreates it the proper way. So that's kind of what I'll show you here tonight. All right, so we have our system user table. We have email, password, the time they were created. I guess I should actually spell created properly here. So let's take this. Created at. There we go. Did not change. Created at. There we go. There's our system user table. So now, I guess now that we have that system user table out of the way, now I like to think of, okay, how do I want this to work? And this is honestly my favorite part about database design is we get to kind of think through all these problems, and the decisions we make here will actually define how our application works clear till the user experience. So, data design is really important. So the next thing I'm going to do now is I like to start with kind of like the fundamental root of all this. And I'm going to add kind of a layer. Normally I just do a recipe book, but I kind of wanted to put a little spin on this. So what I'm going to do now is I actually want to focus on how do we group families together? Because this is going to be like a family cookbook type thing. So I kind of want people to be able to create a group. So that's actually what I'm going to call this. I'm actually going to call it a family table. So let's call it a family. And inside of our family table, we want to have a family ID that's an integer primary key, not null, auto increment. And we're going to let you give a family a name. We're going to let this be, since we gave people 60 characters for their last name, we might as well give them 60 characters for this. And we're not going to set this one to unique because obviously it might be, you know, Crook Family Cookbook might be the name, and there might be someone else who uses the same, and that's not going to be a problem. But we also don't want to restrict people like, oh, that name's already taken. So we're not going to worry about that. But what I am going to do is I'm going to have an owner ID. And what this owner ID is going to do is every cookbook is going to be owned by someone. Even though it can be shared, there's going to be one person, the creator, that kind of created this. So we're going to put owner ID there. All right. And we're going to leave it like that. But now what we're going to do is we're going to connect this to system user, because we want this owner ID to be the ID, the user ID of the user table. So let's actually call this owner user ID to make it really clear. And those are the kind of things that you can choose whether you want or not want to do. I like to do it just because it makes it really easy for someone to say, oh, it's the owner, but it's their user ID. So then they know exactly which table to go to. And so now I'm going to go to this foreign keys tab here, and I'm going to let it auto name it for me. So FK family 1, and it's going to reference system user, and the owner user ID. So the column of the table I'm at is going to reference user ID. And just like that, we have our little connection. Now, one other thing I want to talk about on our foreign key is we have these two options over here, and it says on update, you can do something, and on delete. And what this means, really the on update we won't go over, but on delete. So let's say that someone deletes the user. Do we want to delete the family? Because at this point, if we delete the user, this user ID no longer exists, or it won't let us. So you can see now we can say restrict, cascade, set null, or no action. So if we restrict, which is the default, we say, hey, you can't delete the system user because a family depends on this person, which is ironic. Sounds kind of funny that way. Or we can cascade it, meaning, oh, if I delete my user, the family gets deleted as well, which is probably not what we want to do. The other option is you can set it to null. Oh, this family no longer has an owner, which you could handle logic for that in the background to basically have someone set a new owner if you wanted. But in this day and age, we never really delete anything. So I'm actually going to just say restrict. We're going to basically say you can't. There we go. Now we have a family, and I'm going to start to move just a little bit faster here, and just know that there's obviously more columns I could put in this, things that we might want to track. But I'm not going to worry about that too much right now because I just kind of want to get a base design here. All right. The next thing we want to do is track who can be inside of a family. So I'm going to put a family member. And we are going to go to columns. We're going to say family member ID. It's an integer primary key auto increment. And we're going to want to tie this to two things. I always like to put my foreign keys first. So the first thing we're going to want to tie this to is a user ID. It's going to be an int. We don't want it to be nullable because what's the point of having a record that's not actually tied to a user? The second thing we're going to want to connect to is our family ID. So I just put both those in there and also set this to not null. So now I'm going to go connect those. So again, go to the foreign key tab, double click there, let it automatically do it. I'm going to connect user first, and then I'm going to connect family. So now we should have this little triangle here. And now we can see that based on this, if we look at our little relationship diagrams that we talked about earlier, we have a system user that can own many families. We have a family that can own many family members, and a user can be a member of many families. So kind of like a little, little thing here, but it doesn't seem like a lot, but really what we've done here is we've said, hey, look, a user can be part of multiple families, because let's say you're part of your, your immediate family's cookbook, but then you get married and then you're part of your in-laws family cookbook as well. Maybe you have a Ward family cookbook, or so on and so forth. So, lots of different things you can do.
Ask a question.
Yep.
Did I miss there's a one-to-many relationship on all these, but I don't remember seeing you select that. Did it automatically do that and know which ones to do?
Yes, because of the way I'm doing it, I'm kind of doing it more the manual way, or the more specific way. Basically it's doing this for me because I'm connecting it to a single, because it knows which ones to do, because for example, like on this one-to-many, because family ID exists over here, it knows that this is the foreign key. So it knows, oh, I can put many family IDs here, but family ID can only exist once over here because it's the primary key. So naturally it assumes, oh, only one of these can exist, but many can exist here. Yep. So that's kind of the default. Good question. And for the most part, if you're sticking with first normal form, which honestly I would recommend because it's the easiest, unless you're doing something really complex, which we can talk about, for the most part, almost all of your relationships should be a one-to-many relationship or one-to-one. All right. Let's keep going. So we have a way to group our family. So now let's build a cookbook. So I'm going to put this table here, and we're going to make it actually so families can have multiple cookbooks too. So I'm going to call this cookbook. And this cookbook is going to have a cookbook ID, int primary key, not null, auto increment. It's going to have a name. And this is actually where we need to think about something. Do we want cookbooks to be allowed to be shared between families, or do we just want, like, oh, once you have a cookbook, like, it can only belong to one family? And this is where we'd have to think about that. And I'm actually leaning more towards, no, like, this is a family cookbook. Every cookbook can only be attached to one family. So I'm actually going to make this a family ID here. So basically I'm not building a cookbook sharing application. It's more for a single family to share. So basically, if you're not a member of the family, you don't get access to the cookbook. Keeping the family secret safe. All right, so we have a cookbook ID, we have a family ID, which we're going to tie up there later. Let's have we have a name. Let's have a description. So we can use one of these other columns, which we are going to use a text column. Maybe text. For some reason, it does not want to select that. So let's try it. I don't know why that's not liking that for some reason. All right, so we'll give them 500 characters for like a little short blurb description. And again, we're going to keep this simple. So let me build my foreign key here real quick. And we are going to connect this to family ID. Bam. There we go. So a family can have multiple cookbooks. And again, you might want to add more to that, like a category. A cookbook category is this for baked goods, blah, blah, blah. Maybe you want to do that. But we're not going to deal with that for right now. So inside of a cookbook, we are going to have a recipe. This is where I'm going to start hopefully moving a little bit faster. Recipe ID, int primary key, auto increment. We're going to give our recipe a name. And like I said, I want to limit these a little bit more. So I'm going to give you 30 characters to give your recipe a name, because we want to keep it nice and concise, because maybe we're going to build a mobile app one day and we don't want super long names. So each recipe has a recipe ID, a name. Oh, and I forgot, we want to connect this to a cookbook. The other thing that we want to connect this to is we'll just put it in here. So every recipe belongs to a cookbook, but it also has an author. So author user ID. And that author user ID is going to be what connects it to basically who wrote it. So in this cookbook ID, we want that to be an integer, not null. So every cookbook, every recipe has a cookbook and an author. And now I'm going to put the name of our recipe. We're going to give them 30. And I'm going to do estimated prep minutes as an integer. So that way you can say like, oh, this recipe takes about this long to cook or whatever. And we're also going to put a description here as well. All right, let's connect it up. So first we have our cookbook. Next we have our author. And we're connected. Put these guys over here. So that's a recipe. Now, obviously every recipe has, I think recipes kind of have like two things, right? There's like instructions or steps, but then there's also ingredients. So what I'm going to do is I'm actually going to build a couple of supporting kind of utility tables here real fast. And it's, yeah, we're 40 minutes. So we're actually doing perfect. Okay, so I'm going to build a table that's going to track. Let's start with ingredients. And let's see, do we want to call this ingredients? Yes, let's do. We're going to call it ingredients. You could also call it like products, but we're going to call it ingredients. Ingredient ID, primary key, auto increment, the name of the ingredient. We're going to give people 45 characters, I think should be adequate. And actually, we're going to back up just a second, because I'm going to add one more supporting table here. And I'm going to call this ingredient type. Ingredient type ID, and we're going to give it a name. And that can't be null, so there we go. And basically what this is going to do is it's going to basically track, we want this to be unique as well. We want this to track like certain things like, oh, is this the breads? Is it dairy? Is it fruit? Those kinds of things. So that way, as we build things, it's a little bit easier to classify or find or search for. Because obviously when someone's inputting these recipes, maybe we want to allow them to search by the ingredient type, like, oh, like, are you trying to add milk? Okay, yeah, go to the dairy section, click that, and then you'll find milk in there. So, just something to kind of make it easy. So then in here, we're going to add our ingredient type as a column. Ingredient type ID. It's an integer. We're going to say it can't be null. You have to categorize it. And let's build our foreign key. Ingredient type ID, and bam, we're connected. So there's our ingredient type stuff. The next thing that I want to do is I want to add a way to measure things, a standard way to measure things. So I'm actually going to call this a measuring unit. And this is kind of like the not so fun stuff that you have to do, but we're going to do it anyways. A measuring unit, auto increment. We're going to call it a unit, varchar not null, and what's the name? Abbreviation. That's what I'm looking for. You have to use an abbreviation for it, and it can only be, I'm trying to think, like a cup, let's say 5 characters long. Can't be null. There we go. All right, so there's a measuring unit. Because and that'll make sense here in just a minute. Because now what we're going to do is we're going to start building out how you actually build your recipe. So basically, I think the idea that I kind of want is if I'm the one reading a recipe, I really like the ones that are like, okay, step 1, here's like the instructions, but then here's also all the ingredients you'll need for this step. So that way, like, okay, step 1, you'll need eggs, milk, and butter. You know, I can pull those all out and okay, here's my stuff for step 1. So that's kind of the way I'm going to design this. So what I'm going to do is I'm going to build what's called a step. So I'm going to call it a step ID int primary key, not null, auto increment. And every step is going to have like a short little title, a name, if you will. And we're going to let you have like 60 characters, I think should be adequate for that. You know, and it could be something like, you know, oven prep might be a step name, something like that. And then for every step, we're obviously going to have instructions. And that's going to be long. So we're going to let that be a text up to 500 characters in length. All right. And next we want a sequence. And this is important. Oh, and I'm forgetting one of the most important things. We need a recipe ID. We need to attach this to our recipe. Let's make sure that this doesn't, sometimes it likes to like rename stuff. There we go. Okay. Recipe ID, we want that to be an integer and not null because we'll want to connect that. But then we want a sequence. So the other thing, we want a way that we can sort the list of steps, you know, so like I can say, oh, you know, step 1, step 2, step 3. So the sequence is just the order in which we want the user to progress through our steps. So I'm actually going to move this right up here. And that messed that up. So name instructions, name sequence instructions. Sequence is just going to be an integer. There we go. Step, recipe ID, name, sequence instructions. Perfect. All right, so let's tie this up to our recipe. There we go. And I think that was our only foreign key. Yes. So there's our recipe step. Now what we want to do is we want to tie ingredients to this recipe step. So now what we're going to do is we're going to build a recipe or a step ingredient. All right. Step ingredient ID, again, primary key, auto increment. And we are going to have an ingredient ID, which is going to be a foreign key to ingredient, obviously. And then we're going to have a measurement unit, measuring unit ID. Which is an int as well, because it's a foreign key. And then we're going to have a quantity, which is going to be a decimal, because it might be like 1.5 or, you know, something like that. So we're going to have a quantity. And really, let's see if we want to think about this, because we might do like 1/4 cup. So yeah, let's actually have this just be a varchar. We're going to let it be 10 long because we should need more than that. And then that way, like quantity might just be like a a pinch, and maybe the measuring unit is a pinch, and it could be like small pinch, something like that. So anyways, that could get it, had lots of possibilities there, but that's why I'm going to leave that as a varchar. So that way we have that option. And let's do a measuring unit, connect those, and we forgot our step ID. Obviously we need this to be tied to a step. Which one did it decide to rename magically? Ingredient ID and measuring unit ID. There we go. Let's make sure it didn't mess anything up here. Perfect. Now we just need to connect our step. Our step. And there we go. Perfect. There is our data for the most part. We have ingredients, common measuring types, that sort of thing. All right. I think that for the most part will do it. So I'm actually going to count the tables 1, 2, 3, 4, 5, 6, 7, 8, 9. So I would be one short from what like a final project would be, but don't worry, we can always add a super easy one somewhere along the way. Like we can add like a rating system to this, or something like that. We won't worry about it right now just for the sake of time, but does anyone have any questions about kind of like this whole process here? Any questions just on like how to kind of go about this? Because at this point, so what I would recommend is at this point, if you're doing the final project, maybe start toying around with an idea. And as you're toying around, maybe you want to sit down with a piece of pen and paper and kind of like draw out some ideas about how you might organize your tables, or maybe you just want to dive in and start actually building it. So that's kind of where I would say start for right now. And we're kind of going to want to be working on this for like the next 2 weeks before we maybe start kind of looking into something else. So at that point, does anyone have any questions?
I just think tricky part is going to be finding something to use or a scenario or whatever.
Yes. Yeah. Picking a project and finding a project that's, within scope, because, and just keep in mind, like if it's something big, we just need 10 tables and kind of like one little like user flow. Like, so for example, for me, this might be, what does it take for someone to create a recipe would kind of be my flow. And then view the recipe or something like that. So you can kind of isolate down to a single component, but yeah, finding a project can sometimes be the hardest part. So I'll just throw out a couple of things that I've seen in the past. Obviously it's always good if it's something near and dear to you. So if you've always had like an idea for like something, but I'll throw out a couple of things that I've seen in the past. Obviously a recipe one is always good. Like, even though I did this one, feel free to take your own spin on it. Maybe you want to, instead of doing like a family cookbook, maybe you want to kind of like organize it by like award, or have it be more shareable to where you share recipes instead of like a cookbook. Stores are always a good one. Different iterations on stores. I've seen ones where someone did like a shoe customization where you pick like, the color of your laces, the color of the logo, the color of the sole, and, design your own shoe type of thing. So lots of different options in like the retail product customization space, obviously. A couple other ones, someone did one on U2, the band. Like they built a database of all their songs and albums and tours and stuff like that. So even think of something as simple as like a Wikipedia for like a singular purpose. So like maybe it's a database to hold music, maybe a database to organize your family photos type stuff. So So those are kind of some of the different options I've seen. Obviously, I've seen more isolated ones. Like someone last term actually designed a database to build like a communication system between joint custody parents, and that kind of thing. So lots of things out there. If you need any ideas, just feel free to ping me, or if you want to bounce an idea off me, just feel free to ping me. But good question. Any other questions or concerns? All right, well, I will let you guys do it. We actually finished on time this week, which is great with 2 minutes to spare. So if anything comes up during the week, feel free to let me know. Otherwise, I hope you guys have a great week.
Thank you.
Yep, thank you.
Thank you.
Thank you.